So, shalom. My name is Yonас Riksinger and I'm with Mטאו-קונטרול. The topic of the presentation, as you see, is grid feed-in management for PV systems. So the agenda, first I want to say a few words about Mטאו-קונטרol, then discussing the question why do we need power quality control, some experience that we have with power quality control. So here you can see the whole bench of products Mטאו-קונטרol is offering, starting in the planning phase of a PV plant with yield reports, manufacturer auditing, while the construction phase, it's the supervision, technical acceptance, and also very important the operations phase where we do the monitoring of PV systems and also operation management. So about Mטאו-קונטרol, Mטאו-קונטrol has experience for more than 30 years in the branch of renewable energies. The two big parts are quality assurance, as you have seen before, and of course monitoring, where we right now are monitoring more than 30,000 PV systems with some power of 7 gigawatts. Mטאו-קונטrol has 100 employees worldwide. So we have branches in North America, Spain, Italy, France, Germany of course. In Israel we are partnering with Ledico Green. And we are also have activities in a couple of other countries. In the field of professional monitoring we are a market leader. So why do we need power control, power quality control? Therefore, I like this diagram. It's showing the situation in Germany. You see the rising of the different types of renewable energies in the German electricity grid. And on the top, you see the minimum load of the demand. And you see 2009, there was the interception of these two curves. So in the bad case that you have a lot of production, a lot of wind, a lot of sun, but a very low demand, like on a holiday, you could have more generation than demand, and therefore, you need definitely to control the renewable energies. So this is more for active power control. The other big point is the reactive power control. There you can see the advantages by supplying reactive power control. The most important one is to limit the voltage drop, so you can utilize your transformer and cables better, or the utility, the grid operator can utilize it better than on the left side if you just insert active power. So this is a very technical slide because I think we are very short in time. I don't explain this one. The key point, which is very important, you also see it bold here, is that if you as plant operator or plant owner are supplying reactive power to the grid, it doesn't goes away from your yield. It's just something the inverters are supplying on top of the active power feed-in. There can be some losses related to the apparent power, but the important point is the reactive power feed-in is not going away from your active power feed-in. Okay, experiences in Germany. In Germany it started in 2009. If you have the slide in mind I showed you before, it makes sense. I think in Israel, you will be at this point, maybe right now, maybe the next few years. The legal framework is that we have the Renewable Energies Law, which is just giving you a very raw framework of what you have to do. Then we have by the grid operators associations directives for the different grid levels, low, medium, and high voltage. And in Germany, other than in Israel, we have not one, but 800 grid operators. So all of them can give you different requirements. So we have experience with a lot of different types of requirements in this field. So here just some examples from the requirements out of the medium voltage directive. Of course, you have to control the active power. For the provision of the reactive power, there are different types how you can do this. You can get a set point by the utility as a fixed value, or head curves like cosinus phi dependent on the active power, also dependent on the voltage, a fixed reactive power value, or a Q dependent on U, so the voltage head curve, that are the most common curves which are used. Also, it is possible that a grid operator switches between the different functions. And important is this requirements has to be fulfilled at a point of grid connection. You don't only tell the inverters to supply this reactive power, but you have to make sure the same reactive power going through all the cabling, transformer, and so on is coming on side of the grid interconnection. So you have to make a feedback control system. These are the supplementary nodes of the utilities of the different grid operators. They are more the technical interfaces between the utilities device and the plant control. So this could be digital signals, analog signals, some IEC protocols, which is bus communication. It defines the support points of these head curves, and also requirements that you, for example, have to send the active power, the voltage, the current back to the utility. I think in Israel the IEC is taking care of this by her own. So this would be an example of such a Q dependent on U head curve. You see an arrow and the x-axis. So until the point U1, there's no reactive power feed into the grid. If the voltage increases further, there is reactive power inserted into the grid dependent on the voltage. And by injecting this reactive power, the voltage increase will be limited, will be lowered. And if somehow the voltage goes down again, in this specific curve we have a hysteresis, meaning if the voltage goes down, the reactive power feed-in stays constant for an amount of time, and then if it drops further, it also goes down. And the other way, if it's increasing and increasing, it goes all the way up. And somewhere the inverters are on their technical limit of supplying reactive power, and it will be limited then. Okay, so how is such a solution looking like? We have the requirement by the utility, the RTU in this case, and we have an interface to the PCU, which is the power control unit, a device from Mטאו-קונטרול, which is the interface between utility and the plant control. On the right side on the top, we have the power quality analyzer, which is measuring on the grid connection point to do this feedback control. For example, if you have to, if you get a set point of cosinus phi 0.95, you give this command to the inverters, but through the effect of the transformer and cabling, you get at the grid interconnection point maybe just 0.96. So you have to change the cosinus phi at the inverters. So you give, for example, 0.95 to the inverters, and then you'll get 0.95 at the grid connection point. The commands are sent by the weblog. The weblog is our data logger, where we usually make the monitoring. You can make the operation maintenance in our internet portal. But in this case, the weblog not only gets the values from the inverters, but controls the inverters. And all the power quality control algorithm is implemented in the data logger. So this would be an example, a schematic of a real plant. So you see again the NHG is the power quality analyzer connected to voltage and current transformers. The whole plant control system is connected over Ethernet. And yeah, you have to define one data logger as master, taking care of the control and sending the set points to all the slaves in the system. And here you see an example how the connection or the interface between the RTU and the power control unit works. So we have, for example, here 100%. The grid operator is giving to the PCU, and the PCU has to send an acknowledgement signal back to the RTU. Yeah, and that's for all these 5 inputs. So if the utility gives 50% as set point for the plant, we have to give this as acknowledgement back. The same thing for the cosinus phi values. Okay, so we are coming to the conclusion. So we saw grid feed management is reasonable and important for the grid integration of renewable energies. Yeah, in Germany we made the experiences with our 800 grid operators. So we have the assessment to make the coordination, the coordination with the utilities, and also of most important, the system relevant planning and design is very important. So not all systems are the same. So Metacontrol is offering this planning and design as a service. And yeah, our experience now is mostly in Germany and some other European countries. And I think this year will be very exciting in Israel as the big systems are coming now, and the IEC has now these requirements also for the Israeli market. And yeah, we are able to offer a solution, of course, for this market as well. Thank you for your interest.